what we're working on today is dividing polynomials, and we'll be talking about the remainder and the factor theorems. We're going to be using long division. Synthetic, I don't know about it. I'm not a big fan. JK. We're going to evaluate the remainder theorem, and then we're going to use the factor theorem to solve polynomial equations. Before we do that, I want to send you back a little bit to this. Please do this problem real quick.
Without your calculators.
On paper, please. I want you to go through the process.
You can do that without a calculator.
Do it by hand, please.
Yeah, you have to do it by hand or else they'll lose your knowledge. You want the remainder as R?
No, I don't want it as R. I want it as a fraction. I want it as a fraction. Remainders, I want them as a fraction, please.
There shouldn't be a remainder.
No, you didn't get a remainder.
You know, a little secret.
You know, just pull like
I got 12 remainder 2. I got 10
Hold on.
5. I'm just kidding.
Okay.
it.
I don't know if there'll be one. I just made it up real quick, but there, if it all adds up to some number that's divisible by 3, so there should be a remainder. Do you guys know that trick?
Yeah, you add them all up and you can divide by 3.
All right. I'm just checking. Some people don't. They'll be like, what? Just like multiplying with your fingers, right?
Oh yeah, yeah,
No,
the
no,
9
say it.
yeah, the 9
Thank you. Thank you. So I'm going to repeat it. If you already know it, then good for you. But if you want to check if some number is divisible by 3, add up all the digits. So 1 plus 5 is 6. 6 and 4 makes. It used to be 14. 14 plus 4 is 18. If I'm not sure if 18 is divisible by 3, add up 18. 1 and 8 make 9. Can I divide 9 by 3? Then I can divide this thing by 3 evenly. So let's go ahead and go through the process real quick. 3 does not go into 1, correct? But it goes into 15. How many times? 5. So I'm going to get 15. I'm going to change my sign by subtracting. So I got 15 take away 15 is 0. I'm going to bring down the rest of the numbers. I got 84 now. So 3 does go into 8. How many times? Twice. 2 times 3 is 6. And then I'm going to subtract, right? 8 minus 6 is 2. 3 does not go into 2, but it goes in 24. How many times? 8 times. And you've got 528. 8 times 3 is going to be 24. Can I help you, sir? Help you, sir?
Yes, just questions. So there's a substitute. Yeah, for a second.
Hi guys! Yo, I'm ready to shout out to everybody something out there. Hey, have you guys not realized that, like, you know,
I couldn't do that to you when you were driving down in the crash. I dare you. Oh my god, there's a Is this cute?
They really need a password?
Well, the students are saying I don't know if they do or not. I don't know. And he doesn't.
This is Mr. Creekus. Do me a favor. Go to Miss Casabuena, which is next door, and then she can get a hold of him and see if there's a password. Okay?
She can get a hold of him.
She can get a hold of him.
Okay.
Thank you. All right. Thank you. So we have this this quotient. Now let's say that we did have a remainder. All this is important here. But let's say we did have a remainder, I don't know, 2. So let's say we had a remainder of 2. How would I express my remainder? Not R2, I would take 2, my remainder, and I would put it over my divisor. So I would have 528 and 2/3. Anyone remember that process? Yeah. Someone fuzzy on any part of it that I need to explain? We're good? We're good? All right. Caker? All right. So let's move on here. So here I have this problem. Now I just want you to watch as I do this problem, and then you can write when I'm done to your heart's content. The first thing that I want to do is I want to make sure that my dividend is going to be in the proper order. So I'm going to rewrite that. Why do you think I read? 2x to the third minus 3x squared minus 11x plus 7. And this bad boy is being divided by x minus 3, yeah? Okay, so long division works very, very similar, if not identical. I haven't figured out the little nuances, but to me they're they're actually the same thing. When we're dividing though, we're only going to divide by the first item here. Okay? So does x go into 2x to the third? Yes. Yes, it does. And if you can't see it, this is how it divides. It's 2x to the third divided by x. What happens in this scenario? X drops down a level, doesn't it? So I'm going to place my quotient here with my x squares because I want them to line up. You guys remember that place value thing? What's up? Yeah, go for it. So I have that. Now when I multiply out, I'm going to multiply by the whole thing. So 2x squared times x is going to give me 2x to the third, and then I'm going to get negative 6x squared, yeah? Then I'm going to subtract the values. 2x to the third minus 2x to the third is gone. I've got negative 3x plus 6 will give me 3x squared. And then I'm going to bring everything else down that I have left over here. And then I'm going to start that process all over again. Does x divide into the first number? Yes. What would I get? 3x. So I've got plus 3x. I'm going to multiply it out again now. I got 3x squared minus 9x minus 9x. I'm going to change the sign because I have to subtract. 3x squared minus 3x is going to give me 0. Negative 11 plus 9 is going to give me negative 2x. And then I'm going to bring down everything else. I'm going to continue the process. Can I divide negative 2x by x? What would I get? Negative 2. Multiply it out. I've got negative 2x plus 6. I'm going to change my signs because I have to subtract here. This is 0, and then I've got 7 minus 6, which is 1. So I have a remainder of 1. I'm going to place that and put it over my divisor. And there is the quotient of this problem. You can write down anything you want now. Or take a picture. It's also on YouTube. What's up? If you're doing long division, no. Now, do you need to know long division? Yes. Because sometimes you're going to be dividing by things that have a higher degree than 1. And what I mean by that is sometimes I always forget these things. My divisor is going to be a binomial greater than degree 1. And I have to be able to do it that way. Okay? This might be an x squared or to the third minus 3 or something like that. So for those scenarios, I need this method. You need to know this method. Now to answer your question, is there an easier way? There are other methods that I can use if I'm doing a first degree binomial. Okay? I want to make sure that we got this first though. I don't got it? Where? Which part?
No. Like the beginning.
Okay. I'm going to wait for everyone to finish writing, and then I'm going to do it one more time, okay? And then stop me.
You don't gotta do it.
Where you, no, I'm not going to do it slowly. Take that waste of time. I'm going to just do regular speed, and then you let me know where you ask me where things are coming from, okay? Because I don't think you're the only one with questions.
I just look at his face and I just
Okay.
feel-
Can I erase this?
No.
Nope. Thank you. No, I'm gonna cry instead. Ever happen to you guys? Like, if you don't sneeze, but instead you get a little tear that comes out?
Spontaneous crying, yes.
I don't think it was spontaneous. Oh, and I can feel it right there, like, So my wife just got me some new sneakers too. And like, I like my red and gray. Like, I graduated Santa Cruz and those are our colors. But then she's like, you can't really use those to work. All your tops are like blue or black. I'm like, well, you make a good point, so I'm gonna go switch them out for my blue and gray. They don't have blue and gold, but it is what it is. Alright, can I get rid of this now? It looks like you guys are good. Alright, so let's do this one more time. Please ask me where you have your questions. So, I've got 2x to the third. It came from the given. It was given to me. Which part don't you understand? Oh, that was a bad joke. Keep working on it. It will happen. It will happen. I need a, what do you call it? A drum roll? No. Is that what it's called?
No.
What's it called?
Yeah, just call it a whatever.
No, it's not.
Okay, I need a soundboard with all the sounds I like. You guys remember the easy button?
Oh, yeah.
I had an easy button and I would hit that every once in a while, like that was easy. Okay. So, thank you. So when I want to divide this, you actually just start dividing by that first part here. So only when I divide do I use this piece only.
And that's what goes on the top.
The quotient goes on top. So remember how we would say, oh, does 3 go into 1? No, it doesn't. But does it go into 15? So we're looking for that first number, correct? In our problem, it's already broken up into these terms, right? So I'm going to check if x goes into the first term. And I can do it like this. This is 2x to the third being divided by x. What does this quotient simplify to? 2x squared, right? And all I'm going to do, JK, 2x squared. So what I'm going to do with this 2x squared, oh no, okay, whatever, is I'm going to write it with all my x squares. So this is 2x squared. And the reason for that is I want all my x squares to line up. I want it to look pretty. Math is supposed to be beautiful. Okay? What? Silencio. Silencio. Now I'm going to just multiply like I normally would, right? But I'm going to multiply by the entire binomial here. So 2x squared is going to give me, 2x squared times x is going to, so here's what I'm doing. I'm taking 2x squared times x minus 3, which is, of course, a distributive property, right? I've got 2x cubed minus 6x squared, correct? Okay, cool. So the next thing I would do is subtract. So I've got to change all the signs on this number. Whatever number that is, I don't know what it is, but whatever. 2x to the third minus 2x cubed minus 2x cubed is 0. Negative 3x squared plus 6 will give me this, right? And then I would bring down my numbers. Remember that? Cool. Questions? Any part? Rinse, repeat. That's all we're doing now. So now we're going to do, does x go into the first one? Yeah, it does. What would it be? 3x. So I'm going to put my 3x here, and I'm going to multiply out again. So 3x times x is 3x squared. 3x times negative 3 is a minus 9x. I'm going to change my signs. And then, let's see, that's gone. I'm going to get, what is it, 2x? 2x plus 7. And then, oh yeah, cool. Hold on. What? Yeah, negative 2x plus 7. That's okay. No. You're okay. That's why we do it together, right? So, Lil, we're still good? That's all we're doing until we're done. So, does 2x go into negative 2x? Sorry. Can negative 2x be divided by x? Yes, it can. You would get a negative 2, multiply it out, negative 2x plus 6. Change the signs. That would be 0. That would give me 1. Does x go into 1? No. So that's my remainder. So now I'm going to put my remainder over my divisor. And there's the quotient. Okay? Now, you already wrote it down, right? So I can move on?
Mr. Bruce, I have a question.
Yeah, what's up?
What happens if you divide by a square, like a higher degree than one?
Then 1?
Yeah.
Same thing. So here, let me erase this.
Yeah, I just need like a quick example.
Yeah, because it's just as easy. And this is why we need this. So let's say this was x squared minus 3, right? So check it out. This is kind of cool. I'll do this one just because you asked for it. Okay? Can I divide 2x to the third by x squared? Yeah, I would get 2x. 2x goes here. Right? Because see how all the x's line up?
Oh, yeah.
Okay? I want to make sure that I have every single space. Then I'm going to multiply it out. So I've got 2x times 2x squared is 2x cubed. What is 2x times negative 3? It's going to go right over here. You see that?
Whoa, brother.
Doesn't that just make sense? We got to make sure that they're in place value, correct? And then what we're going to do is we're going to change the signs. So this is 0. I'm going to bring this guy down. This is going to give me negative 5. X plus 7. Is this divisible by this?
Yes.
How much?
Negative 3.
I'm going to get a negative 3. And then I'm going to multiply it out. So I'm going to get negative 3 x squared plus 9. That's going to go over half. I'm going to change my signs. This is gone. I've got negative 5x and I've got negative 2.
That's the remainder, right?
Just explain it.
Hold on. What?
No, that's 16.
That's a positive 7 minus 9?
He said 14.
Okay, I'm right?
Yes.
Okay,
Yeah, you're
just
good.
give me some good.
You're good.
Can I divide negative 5x by x squared?
No.
Guess what this is?
That's your remainder.
That's my remainder. So I've got plus negative 5x squared. Sorry, not 5x squared.
Just 5x.
Yeah, so 5x.
Negative 5x.
Ah! Why for you no right? Negative 5x minus 2 over x squared minus 3.
That's it.
That's it. No big thing, right? Thank you. Thank you. So, there's what you would do if you had a higher degree. This is why you would need to know the long division. You can divide by a trinomial if you needed to. That's totally doable. It's not fun, but the process is the same. And that's why I encourage you and I push you, not push you really, because we've only done it twice, but I keep putting all of my stuff where they belong, don't they, line up? Because then you can see what's going on and how the numbers combine. Some teachers don't really care where you put this stuff, and then that just confuses people sometimes, or students I should say. But if you line everything up, look, if you go kind of scroll down, see how my x cubes are here? All my squares are there, these are all my x's, all my constants, and finally my remainders. So it lines up really, really, really nice. Okay? Can I move on? Okay, so the question was, is there an easier way to do this? Is there an easier way to do this? You can, now listen carefully here, Taylene. There is an easier way to divide, but it only works when your divisor is a first degree binomial. So whenever we were doing this was not an option for this method I'm going to show you, okay? Let me go ahead and take the same problem, and this is called synthetic division. With long division, with the other division, what we're doing is we are constantly subtracting and dividing, right? Subtracting, dividing, subtracting, dividing. Every operation has an inverse. And most people like the inverse of subtraction and division. We like to multiply and add, right? That's much easier to do. And this is what synthetic division takes advantage of, which is addition, subtraction. So the way this is going to work, because we're using a fake form of division, here's what our symbol looks like now, okay? It's going to be flipped over. Instead of placing up front this divisor, we're going to place in front what would make that 0. So what would make x minus 3 0? What would x have to be?
3.
So we're going to put 3 up front. Okay? And then we're going to place all of the constants in order, of course, from the highest to the lowest in standard form. So we have 2, -3, -11, and then a +7, correct? Now, this is really nice method because it's fast. It's add, multiply, add, multiply, add, multiply. What do we start with? Add. I should say combine, but it's add. Even if you're adding a negative number, you're still adding, correct? So, add, multiply, add, multiply, add, multiply. You guys good with that? So please watch me do this, because it's going to be pretty fast. So I'm going to start by adding. I've got 2. 3 times 2 is going to give me 6. I'm going to add those. I get 3. 3 times 3 is going to give me 9. I'm going to add those. I've got -2. I'm going to multiply, and then I'm going to add those. And here is the quotient. We'll talk about that later.
Are you serious?
Okay, how does this become my quotient? Well, remember, if I'm dividing a 3rd-degree polynomial by a 1st-degree polynomial, all of the x's will drop down by a level, won't they? So this is 2x squared plus 3x minus 2 with a remainder of 1. And there's our quotient one more time.
How do you know the ones for remainder?
Because it's at the end,
Oh, okay.
and it's not a 0.
Oh, okay.
If there was a 0 then, there is no remainder. So let me repeat this one more time. The last number, if it's not a 0, then there's a remainder.
And that is the remainder, right?
That is not a 0, therefore, that is my remainder. What's up?
Can you go over how you find the first numbers to the 6 times and the 6 again?
Okay, I'll do that one more time because that's really fast, isn't it? Let me clear this up. We're going to do it again. Comma tape. Comma tape. Up front, what am I placing here? 3, because that's what would make that 0. My constants.
I'm so dumb. I am so dumb.
Here we go. Now I'm going to do this a little bit slower. Now, realize the other one wasn't full speed either. That's how fast you could do these. So, I'm adding. That's 2. Okay, so a lot of people, I've seen people do this so they don't get confused. They'll put an X there or a 0 or something. It's up to you. I don't really care for that. But if you want to do that, you can do that. I've seen some people waste their time with that. Like filling it all in. I don't know, whatever. If you're an artist, whatever you want to do is fine. So, now I've already added, right? What's the next step? Okay, so what do I multiply? 3 times 2, I get? Now let's add them up. Let's multiply again. Let's combine them. Let's multiply again. Let's add. Now, you need to know this because this is only a small step to where we're headed. We're going to go into taking a polynomial, not factoring stuff, not quadratic, because quadratics we know, right? We can factor, we can fall back on the quadratic equation. So what we're going to be doing is factoring higher level polynomials. So we're going to be looking at 4th degree, 3rd degree, 5th degree polynomials, and we're going to have to, Mama, no. Yeah, we're going to factor those. Because remember, now we know how to graph them, don't we? If I know all the factored form, I can find all the zeros. And if there's 2 of them, I know that there's multiplicity, and therefore it'll bounce, and I know all this cool stuff.
Cool.
Right? So that's where we're headed. This is going to help us with factoring. Okay?
Like something we can skip.
This is another
Say that one more time?
I
Is
missed
that
last
something we
year.
can skip, or do we have to use that?
No, this is not something we can skip.
I know for a fact this is one of the lessons I missed last year.
Are we good so far? Are we good then, right now? Okay. You try. You try. Let me make this. Here you go. Thank you. Right now, right now? Not yet. 20 minutes. Like in 20 minutes. You can make it down there in 5 months. Use marching legs. I just don't know. Because like marching people walking all day.
Oh, he pulled the sneaky one.
I pulled the sneaky.
Wait.
I did, didn't I?
There's no square.
Yeah, that's the sneaky sneak.
I'm not gonna do it. Well, they can see it. They can see it clearly from there. You can make it up, can't you?
I can see it right so
Yeah. So I'm thinking like, but yeah, the further you get away, the less. But up close. But I'm like, why? And in my mind, I'm thinking he just wants to focus, kind of thing. Like, no. And when I got up there, like, this is what he was doing. Got it, a bastard. Anybody still working? Who's still working? Oh, are you good at that one? Okay. Yeah, baby.
No remain exists, dude.
It was a nice latte cup, but it's
Brown?
literally just stop. Stop. Your presence. Your vibe. It's like I know it's
What goes here?
0. Nothing, absolutely.
And then?
1.
And then? And then? No, and then. Sorry, just kidding. 4. Combine them. Multiply. Add them up. So I got no remainder. So what's my polynomial? Beautiful. Beautiful. Okay, let's carry on. Thank you. Wait. Lily, you good?
Yeah, I know I did. It's cold.
Okay, good. Thank you.
Right.
Okay, so we've already said once I'm done dividing that last number, if it's not a 0, then that's my remainder, correct? Cool beans. So that takes us to this thing called a remainder theorem. If I get to the end and it gets a 0, then that means that technically, do you guys remember my first problem that I made you do over here? That there really wasn't a remainder? That means that 3 is a factor of 1584, correct? Same idea with our polynomials. If we don't get remainders, then that means that what I was dividing by is a factor of that polynomial. Does that make sense? Yes. Cool beans. So, now here's a question. Oh, this is so cool. This is very cool. All right, so using the remainder theorem to evaluate a polynomial. Do you guys remember how we used to plug in -4 and then do all this crazy math? Guess what else we could do? We could just use synthetic division to figure out what that is. So if I did 3, 4, -5, 3, I could evaluate this really quickly, couldn't I? What's that going to be? -12, I've got -8, that'll give me 32. That'll give me 27, multiply that out. 80.
108.
Is it 108?
It'd be a negative 108.
Negative 108? And then I would get negative 105. F of -4 is negative 105. Now, let's verify that, just because we're geeky like that, right? So let's do that real quick. 3, -4 to the third, plus 4 -3 squared, minus 5 -3. Why am I putting 3's in there now? It's not 3's. My 4's became 3's. -4,
Why are you writing so far?
-4, because it doesn't fit over my arrow. All right, so what is this? This is what's here? I'm gonna use my calculator because I don't know how to do it in my head. 16 times 4, yeah, that's 64 times 3. That's a negative 192. 16 times 4 is 64. This will be a positive 64. This would give me a negative 20 and then a positive 3. Sorry, positive 20, right? So I got negative 192. What am I taking away? 64, 84, 87. Okay, so 192 take away 87 is a, whoa, something's wrong.
It's 105.
105? There it is right there too. Boom. Pretty cool, huh? So questions on the remainder theorem? If you don't feel like plugging stuff into the polynomial, synthetic division.
It's big brain time.
Can I move on from here? I want to make sure you guys don't have questions on this. All we're really saying, hey, I want to evaluate a polynomial. I don't really feel like plugging into that bad boy. I can use synthetic division. And my remainder would be the solution. All right. Oh, I only have one more slide? Sad face. Okay. Okay, thank you. So here's what we're doing. We're trying to find all of the x values, right? All of the zeros in this case. And I think I told you a minute ago. What we're going to do eventually is we're going to be able to factor all these cubes so that we get all the different factors. What's nice about this is that I already know that Whoa. Whoa, oh, wait. No, not you. I already know that's -1. That -1 is a 0. Okay? So, that's kind of nice because I have a good starting point, don't I? So here's what I'm going to do. I've got 15, 14, -3, -2, 3, 2, 1, none. Good. And I know that -1 is a 0. Question.
No. Why are we dividing?
What am I going to get at the end here?
Zero.
A 0. Because I already know that this is a 0. Okay? So here's what I want. Here's what I know. I know that x equals -1. Okay? So because we already know factor and all that good stuff, we'll use synthetic division to get to a certain point, and then we'll use our other tools again. Okay? So in this case, we're just going to go through this. So I've got 15. This will give me -15, -1, 1. That'll be a 2 negative. Yeah? And that gives me a +2. And no surprise there, right? So now I know that I've got 15 x squared minus 1x minus 2. At this point, I want to factor this. I could factor it, or I could keep using my synthetic division if I had more choices to kind of divide by. But I don't in this case, do I? So we're going to have to factor or use quadratic equation. What do you guys want to do? Yeah, why not? So this is 30. 5 and 6. 5 and 6.
That's what he said.
Oh, I didn't hear you. Sorry. I was in my zone. This is going to be negative. This will be positive. There you go. So, what?
It's wrong.
Oh, that can't be. All right, let's use quadratic then. I was trying to use a little Xbox. I was trying to use Xbox. Remember that? No? No Xbox?
I never had 3x.
Hold on.
What about that?
Thank you. Thank you. Okay, so we've got square root of 1 plus, what is this? $1.20? So yeah, there's a square root of 121. So that is factorable. Okay. You guys ever seen Xbox? Let's try Xbox real quick. It goes like this. What's the product of these two? Negative 30 x squared. We're going to put that negative x right here. I'm looking for two numbers that are going to multiply to 30, and they're going to combine to my negative x here, which was, I thought, negative 6x and a positive 5x. So here's what I'm going to do. For my x, I'm going to go to my box, and I'm going to plug in my first one in the first box, my last one in the last box. I'm going to put my 5x here and my negative 6x there just because I can. Let's factor out a common factor going up here. 3? You mean 5x? And what can we factor out here, common factor? Negative 2. Let's factor this way. What do we can factor out in common? 3x in that case. And then going this way, just a 1, right? So there's my two factors. So we've got 5x minus 2, 3x minus 1, and that works, right?
No, it's not minus 1. It's
Plus 1. Double check that. That's my 5x. That's going to give me 5 minus 6 is a negative 1. Yep. Thank you. So I've got my two factors from factoring this bad boy. I'm missing one, aren't I? I'm missing where the x equals 1. How do I write that as a binomial? I do this. I'm going to add 1 to both sides. That's gone. Therefore, x plus 1 is equal to 0. I can replace that over here now as an x plus 1. And there it is, totally factored. Totally factored. I'm going to go in full screen on this guy so you guys can see all the parts to it. Whatever you want to do is all right with me. It's common factors, yeah. So I took out common factors this way and then that way. And then whatever it comes out is your are your two binomials.
Clearly a derpy draft.
So, oh, the x plus 1? From the 0 they gave us. They told us that x was equal to negative 1. So we just moved the 1 over. Got x plus 1 is a 0. And then plug it in there. Which part?
The X.
The x part?
His value from.
I'll show you right now one more time. Can I get rid of this, yo? So can you see from here just fine? So to get the top one, I'm going to multiply the first and the last one. So 15x squared times negative 2 is negative 30x. And then I put the middle one at the bottom. I'm looking for two numbers that multiply to this. And when I combine them, I get this. And those were those two. That's where I put them here. And then the first one goes the first box, the last one goes in the last box. And then I just kind of factor out. You never factored that way? I'd seen it before. This year I'm pushing a little bit more. Just for values that where a is greater than 1. Because when a is 1, it's a waste of time. That doesn't make sense. It didn't make sense to me for a long time because I'm a guess and check kind of person. But I need it for my lower levels. It makes more sense to them. And then get used to it. Malia, I'm done. You want to head out? Collect your stuff. Any other questions? Going once, going twice. Okay, so now that I have my x-intercepts, what's my y-intercept? Nice enough? Negative 2 is, well, yeah, I guess so. It should be 0, negative 2, but yeah, you're correct. I don't like the way that MATLAB sometimes makes you put in the 0.